I'd like to make a quick announcement that there was an issue with the program survey on the guidebook app. So if you're trying to fill that out and ran into an issue, please go ahead and try that again. If you haven't filled out a survey, we'd welcome your input and ask that you do that. I'd like to now introduce Elisa from BigWave IT and Dave from Spotify to present on network automation and abstraction and a few other words in there.
Thank you very much. All right. Welcome, everyone. We're here to talk about network automation. Specifically, we're going to introduce a tool dubbed Napalm, which stands for Network Automation and Programmability Abstraction Layer with Multivendor support. Napalm helps you interact with a set of multi-vendor devices, as the thing says. This is David from Spotify. He has been working on SDN and automation type of things for the network engineering team at Spotify. And I'm Elisa with BigWave, and I've implemented a number of tools for large-scale networks in the past. I'll start out by giving you a quick overview what the tool does and what it is. And then David is going to fill in the rest of the time pretty much with a live demo here on stage to show you what we can do and... Sorry, thank you very much. To give you an idea what the tool does and how powerful it is. So when you write code, as soon as you do something more than one time, you generally you generalize it out into a reusable subroutine. And if you're a good programmer, you do that on the first pass. If you do what I do, you typically notice on the second pass that you're doing something the second time around, and then you make a subroutine out of that. This is how we should generalize our network configurations into services that span our entire networks and then get pushed out automatically by some tool. The problem is the rolling out part. Apparently netconf is going to be usable and unified across all vendors that we have available real soon now. And yeah, unless you're running a Juniper-only network, you're pretty much out of luck right now to do anything across an entire set of devices. So in the meantime, we needed some way to work on our networks and get those configurations. And if you already if you already have a way to template your configurations, you need some way to get this out there. So David and I joined forces a couple of months ago and started working on Napalm, which is a Python library. We open sourced it, so it's available on GitHub. We're going to have the URLs in the presentation later for you guys. And the main goal was to unify access to the various vendors and provide methods to manipulate configurations and retrieve data from them. Now, those are the vendors that we currently support. Arista's EOS, Juniper's Junos, Cisco's IOS XR, and FortiGate. Mainly because those were the vendors that we were using at that time, and that's what we needed. For some of them, there were already existing libraries so this is a pure abstraction layer. For some, there were existing libraries that we just reused and abstracted them so they all do the same for each of the vendors. For others, there was no library available, so we wrote them ourselves, and now those four are covered. Now for those four, Napalm supports this set of methods. Mainly in the first version, we were mainly looking at loading up configurations, looking at a diff. If you don't like it, you can discard it. If you like it, you can commit it. But then each of the vendors natively kind of has the little, Juniper does the override a little different, and then on Cisco IOS XR2, and then you do a diff here, and it looks like a proper diff, or sometimes it doesn't. So we made sure that on all the vendors that we support, all of that is unified. In a second version that we're currently working on, which is in beta right now, but actually the version that the demo is going to be based on, that you're going to be seeing in a moment here, we're adding the ability to retrieve information, so get certain data, just regular facts, interfaces, or, I don't know, do a show IPBGP neighbors on your entire network devices of different vendors. So we're working on that right now, but this is also on GitHub in a separate branch right now. In addition to that, we provide an Ansible module, which is in the library as well. For those of you who don't know Ansible, it's an agentless automation framework, very popular in the systems world right now. David is going to be using terms like inventories and roles and playbooks later on. Those are kind of the Ansible terms where you put your configurations into, and it also provides templating capabilities. So that was one of the natural ways to do some templating and then try and push and use Napalm and the modules we provide to push your configurations out. All right. So without any further add-on here, David with the demo.
Thank you very much, Elisa. As she mentioned, I'm a network engineer at Spotify, and I'm going to demo right now how we do config management at Spotify. This is not a tutorial, so I'm going to just show you what we do. I'm not going to go into the details of how to do it. The Ansible code, the templates, everything is on GitHub. I will give you the link later, so you can actually check it out offline and just go deep in the details there if you want. But now it's just, I just want to show you what you could do with something like Napalm plus Ansible or some other automation tool. I have a lab in my network which we are going to build from scratch. All the devices have been pre-configured with only the management interface, a basic user that we will use to connect, and just the API netconf configuration. That's it. The rest, we are going to build it from scratch. It's a leaf and spine architecture or cloche network. We have different vendors. You can see, like in the spine, we have a Juniper switch. We have an Arista switch as well. Then as leaves, we have a couple of Juno switches, and we have an Arista switch as well. We are going to have a couple of VMs to test connectivity and check that everything is working. And we will have a router running iOS 6R and a firewall running FortiOS, FortiGate firewall. We are going to be routing down to the leaf using BGP as IGP. And as we are routing down to the leaf, in order to isolate all the security domains, which we have 2 of them, the blue and the red links, we are going to use VRF Lite. I don't know if you are familiar with these technologies, but if you are not, we can just take it out. We can talk about it later. Now I'm going to go through some slides about the Ansible setup. I'm going to be very quickly through them, just so you can see how we use Ansible with Napalm. This is just the inventory file. This is the data center one, which has a couple of spines, have some leaves, and some network services. What we do with the devices is we break down the devices into different services. When you combine all the different services for that particular device, the result is the final entire full configuration of the device. So, for example, you can see that the spine has the basecon at the IP fabric service. When you combine those 2 services, you get the full configuration. Baseconf is just some basic configuration like login, SNMP, AAA, things like that. IP fabric is well, all the BGP configuration to build the fabric, the VRF Lite, etc. The leaves, in addition, will have some access service that will provide the VLAN connectivity down in connecting to the host. The firewall, we have a couple of other services, and the same for the router. When we build the services, what we do is we build templates per vendor. So, for example, what you can see here is how you would define a VRF on Arista. And here you can see how we would do exactly the same for Juniper. The thing that you have to note here is that both templates provides exactly the same functionality and both requires the same input. the idea is that the services should provide the same service. So it's completely vendor agnostic. You just have to adapt the syntax for every vendor, but other than that, you get the same functionality, the same input, so it should be fine. As I mentioned before, when you compiled all the services, what you get is the full configuration. What we will do then, you will see it later, is push the entire configuration to the device, get a delta, and apply only the delta to the device. But you have to think that we will push the full configuration on every run. Then we just have to define some basic data for the entire data center. Here you can see a couple of users, the management gateway, the DNS, NTP, some interconnect ranges for building the IP fabric, the VRF data. Here you can see the data for the network services. The first group, for example, are how we build the policies for the firewall. You can see, like, yeah, we want to allow from front end to back end, we want to allow ping. That's about it. Then we have a couple of peers that we want to configure on the internal router. All the data is there, so it should be. And now we go to the data for every particular device. Here you can see what you need to deploy the Spine Zero. This is everything you need. You only need an ID, you need to tell the system which operating system is running, and then just the management IP. That's the unique data that that device is going to have. If we go to the next slide, you will see the same for the other spine, which is Arista. It's the same data for both. The only difference is that you have different actual values for that data. Before it was ID 0, now it's ID 1. Now we have a different management IP, and we have a different operating system. But other than that, you need the same data. You are going to provide the same data for the same kind of services. And the same for the leaves. This is an access switch running UNOS, and this is an access switch running EOS. In this case, the UNOS switch has more data, but that's because this switch has an extra service, which is the service that is connecting to the actual firewalls and routers. But other than that, it's the same input for the same services. You have the management IP, the ID, the operating system, and then you have the VLAN mapping. That's going to map which VLAN you want on each port. This is the code for the plugin that Elisa mentioned. It's the getFax module. As you can see in the highlighted text, this is everything you need to get the fax for all the vendors that we have in the network. Remember that we had 4 different vendors, and we only need 5 lines of code. Napalm will abstract the details of every vendor for you. Just need to get the correct driver to connect to the device. So that's the first line, get network driver. So you just send him, yeah, this is an EOS switch, this is UNOS switch, this is iOS XR, whatever. And then you just connect, get fax, done. As simple as that. And the same for deploying configuration. There is more code here, but same concept. You don't have to care about the vendor. You only have to care about what you want to do. And this is the play definition. Again, completely vendor agnostic. You don't really care. You only have to provide as a variable the operating system that you are running on that particular box. And this is everything about the Ansible setup. We're going to build now the network that I have in my lab. We are going to do it in 4 different stages. That's only so I can explain you what is going on every step. I could actually deploy the entire network in just one go, but that would be just a bit confusing. So the first thing that we are going to do is build the IP fabric and the access layer. You have down in the slide the actual command line that we would need to run to do that. So let's go and do that. Good, the VPN is still working. And the first thing we are going to do is we are start running MTRs on the different VMs to see how the network is being built at every stage. So let's do an MTR going from this front end to this other one. There is no connectivity because everything, nothing is connected yet, configured. And from this front-end device, we are going to MTR to the backend. And finally, on the front-end servers, I'm running just Nginx and the port 80 just to test connectivity. We can see that right now it's not working. No connectivity at all, as expected. I can go quickly through a couple of devices to show you that nothing is really configured, in case that you don't believe me. This is a Juniper switch. It's bootstrapped only. Show conf. As you can see, it only has the management interface. Netconf is enabled. It has a user, so I can actually deploy my changes. We can go to the Arista spine. Same here. Configuration is empty. Only management interface, eAPI is enabled, and a basic user, so I can connect to. So let's start. To avoid problem with copy pasting, I have a few bash scripts to just execute the command because I didn't want to have problems copy pasting. So, but you can see the command that I'm actually running is the same as in the slide. So what I'm doing right now is I'm compiling all the services for every vendor. I'm getting the data from the YAML files that I showed before, and I'm building the full configuration for those devices. Then finally, that configuration is going to be pushed to the device. I'm going to retrieve a diff, a delta. I'm not going to actually push any change yet. I'm just going to get a delta, a diff, and check it. If I'm happy with the change, then I will actually deploy it. We can, for example, check the delta for the spine running Junos. Compiled, spine 00.demo. This is the running config. I mean, we just generated the entire configuration for the device. And we can check the diff. Here's the diff. This is the diff from the candidate configuration, which is the one that we pushed compared to the running configuration. That is the configuration that is actually running the device right now. So this looks good. Let's check the Arista box. Same here. We are adding some configuration, some roadmaps. It doesn't look as nice as with Juniper, but well, anyway. So now that we are happy with the changes, let's just see what happens if we really, if we apply the changes. Stage 1, commit. Now we skip all the compiling the configuration because we already did that, so there is no point in doing it again, and we are just getting that running configuration, candidate configuration that we compiled before and pushing it to the devices. Okay, it's going through. Come on. Now we go to the device. You can see that the prompt changed. Now it's not in bootstrap mode anymore. If we do a show conf, we should get a lot of more configuration. We can actually do show BGP summary instance front end. This is one of the VRFs. We have BGP that now is configured. It's coming up. Now it's up. The other one. Good. We can go to the Arista switch. The prompt has changed as well. Show run. And we got a lot of new configuration that we didn't have before. Let's check. BGP is up, good. So far nothing broken. And let's check the MTR. We go to the front-end switch. Suddenly I have connectivity between one front-end and the other front-end. Remember that one front-end VM was in one switch and the other one was on the other switch, but they were in the same VRF. So that means that you could have connectivity between going through the firewall. So this is working good. We go to the front end. Now we have one more hop, but still I don't have connectivity. Now the front end has connectivity with the access switch, but still the access switch doesn't know how to get to the backend because it's a different VRF. So we need someone leaking prefixes between VRFs, which is the firewall. The backend still has no clue how to. Sorry. Yeah. So now the second step. Now we are going to connect the devices, the network services. We are not going to actually deploy any service yet. We are just going to connect these devices to the network. Right now, they don't have any configuration, just the bootstrap configuration. So they are not even peering using BGP with the lift. So just let's do that. Stage 2, dry run. Again, I'm just using these bash scripts just to avoid copy pasting from the slides because it's a bit messy, the line is too long. And I'm just doing these multiple steps just to make it easy to explain what is going on at every step. Changes are idempotent. I didn't mention that. That means that if I can run this as many times as I want, but if there is nothing to do, nothing will happen. You can see that now only the firewall, the leaf one, and the router had changes. The rest was just like, well, I had nothing to do, so nothing to do. So let's check what is going on here. We can go again through the diffs, diff 0.1.demo, diffs. The only thing we are doing is configuring the BGP towards the network services. And we can go to the firewall. The same here. We're just configuring a few interfaces and BGP, and the same for the router. So let's just apply the changes. Pushing the changes. This is the critical part. Only one to go. Huh. Well, something broke. Well, the good thing about this is that, as I mentioned before, changes are idempotent and they're atomic. That means that something broke. So either all the new changes went through or nothing went through. So what we can do is rerun the tool and see what happens. I mean, the lab is running far in the cold Sweden, so there can be a lot of things that can break in the meantime. Maybe some shark biting fiber. Apparently the change went through before. Just I didn't get the OK back. So now the firewall should be configured, I hope. Let's go to the leaf and see if now we have. Oh fuck. Shit. If everything went fine, now I should have a part of the two spines as BGP enabled. I should have as well the firewall in both VRFs and the router only in the front-end VRF. So let's check. Instance front-end. Perfect. We have 4 neighbors. That's what I expected. And 3 neighbors here. Perfect. So even though we had that small problem running the tool the first time, everything went fine, thanks to this idempotency and everything. So if we go now to the MTR, yeah, exactly. Now I have a few more hops. Now the leaf knows how to get to the backend device, but the firewall is not allowing that connectivity. So what we are going to do is now we are actually going to deploy the services. This is this step, nothing really interesting in the slide. So telnet is still not working. So now let's run the stage 3. Oh, something I want to show as well. If there is some change done outside this tool will kill that change. As I mentioned before, we are compiling the full configuration that we want. So if a human goes here, let's go to the spine, for example, and let's create a VLAN. Name, whatever. How many VLANs have that name? And now let's run Ansible again. So now what I'm going to, damn it. Yeah, let me fix this on 1 second. That's what happens when you improvise. Yeah, I'm just trying to keep I was trying to keep it easy, but anyway, dc1.spines. So now let's, yeah, I was skipping before the spines just to do it faster. So now what should happen is that we are going to deploy the firewall policies. We are going to configure all these peers that we have defined in that YAML file. And if everything goes as expected, that VLAN that I created outside my services definition should go away. Yeah, you can see that Napalm detected some change in that particular spine. There are changes, obviously, in the router, in the firewall, but no changes in the spine. So we check the diffs compiled. Spine 00 demo diffs. Sorry, it was the spine one. Yeah, there is no change in the spine 0. And there is this VLAN that is going to go away in the spine one because it's not part of my service definition. And we can check the same for the firewalls. Firewall, you have all the address entries that they are being created, the firewall policies, address groups, and the same for the router. Sorry. All the BGP neighbors. I'm not pairing with any of these BGP neighbors, so I'm just going to push the config, but nothing is actually going to come up. Let me change this again, because I have to change this. Commit. And now, if everything goes as expected, this MTR should complete quite soon. Now, everything. Thank you. Now, if we do this telnet, it should work as well. And yeah, as I said before, I was doing all these steps just to show you what was going on all the time, but I can just execute this line, and then I would deploy the entire network in just one go, which is faster than going over 4 different steps. Actually, I want to do something more, which is a bit risky, but let's do it. Why not? I haven't broken yet anything, so. Someone probably noticed that the interconnect range that I'm using is not private IP space, so we are going to fix that. This line I'm right now on, it's defining which range I'm using in the first spine to connect to the leaf. So we're going to change it to an actual private IP network. We are going to change first one spine, hoping that we won't lose connectivity because everything should be dynamic and should go to the other spine. So let's do, now we are going to use this unified deployment. We are going to run everything in one go instead of the full. So now what should happen is that I'm going to reconfigure all the interfaces in my IP fabric, and that means that I have also to reconfigure all my BGP neighbors. There is no change in the spine 1 because we decided that we were going to change only the spine 0, but there are changes in the other leaf and in the spine 0. We can actually change, check what is going to happen. Spine 0.0.demo diffs. You can see here that all the interfaces are changing the actual network and that the BGP neighbors are also changing the IP. We could do the same in the leaf. Same change here, and the same in the Arista one. All the interfaces are being reconfigured, and all the BGP neighbors as well. So now let's do the actual commit, which is the risky part. Let's go to the MTR and see what happens here. So far nothing, which is good, I guess. Nothing yet. That's it. Yeah, well, I didn't lose a single packet, apparently. Let's check that I actually did the changes. Let's go to the spine, and then now the BGP neighbor should have a different show BGP summary. Oh, sorry. Instance frontend. Now we have a different network for my BGP neighbors. Now I could do the same to change the other spine, but I'm running out of time, so I guess that I will skip it. But as you can see, I mean, I just reconfigured an entire network in a couple of minutes without losing a single packet. That was probably a combination of good planning and good luck. So this is everything for the demo. I mean, in summary, what we are doing is we are breaking the devices into services. When you combine all the services, you get the full configuration that you want. That's mainly because we don't want to allow people to configure devices manually. So we want to just wipe out everything that is not done by this tool. We push the entire configuration, we get the diff, so a human can actually check that nothing weird is happening. Like, I mean, normally you do small changes, like you deploy new switches or you change a couple of things, so you should more or less expect how the diff, you should know how the spec should look like. And going back to Napalm, the interesting thing is that if you do it properly, you should be able to build stuff completely vendor agnostic. You shouldn't care about which vendor you are working on. You should just focus on the services that you want to provide. Napalm is open source. You can find it on GitHub, in the Spotify repository. There is a mailing list that I actually opened like 2 days ago, so it's me and Elisa only there. Feel free to join if you want to take a look. The code that I run for the demo, meaning all the templates, the roles definitions, the inventory host, everything is on GitHub as well, so you can go and check it out, and you can just ask questions offline if you have them. And that's pretty much it. If you have any question, just feel free to ask. Lisa.
All right.
So when you're doing diffs, are you doing that diff on the router itself, or are you actually parsing the configuration, creating an abstract syntax tree, and doing a diff of different configuration elements, or is it just like a Unix unified diff?
We are right now getting the diff that the device provides. I mean, you saw that the diffs were different. Right now, I'm aiming to use the diff just as a human check, not to kind of build any machine that could validate the change. So right now, I'm using what the device provides.
Yeah, I'm looking at doing it outside of the device and keeping, like, still doing the human check of the configuration, but doing it completely offline. Like, I don't want a device to do it.
The thing is that I wanted to, as I mentioned, I want to kill any change done by a human. So that's why I want to load the config in the device and get the diff, because I could use the last running config that I compiled in the last run. But if someone went to the device and changed something, I want to know.
Yep.
And I want to find that person.
All right, thanks.
Hi, Steve Feldman, CBS Interactive. Is there any minimum functionality you need on a device for it to be useful in this? Like, for example, old Cisco, regular old iOS devices, would they work?
Yeah, it actually is. The device needs support atomic changes. I can tell you that regular iOS doesn't support that. And the device should provide a way of loading the configuration and replacing the running configuration, which iOS doesn't do either. So today, as far as I know, it's only Arista, Juniper doing that. You could build it yourself. For example, FortiGate firewalls, I do that myself. They don't support any of the fancy functionality. They only support atomic changes. They have something called execute batch that allows you to send a list of commands, and you know for sure that all the commands will go through. So in that particular case, I wrote my own library to interact with those devices, and I'm building the Delta myself. But that was because I hate firewalls, and I wanted to get rid of them and automate them. Otherwise, I wouldn't have done that. But yeah, you need that basic functionality unless you want to build it yourself.
Right. Okay, thank you.
Hi. Michel Moreno, Criteo. We've built some kind of same system. How far off are you, and what's other vendors that do not have atomic change do you support?
I mean, the only vendors that we support are the ones that you saw on that slide, mainly because, I mean, I open sourced this tool, but this tool I built it for my own use. So I only added support to the devices, and Elisa as well, for the devices that we cared about. If there is other vendors that might be interesting to have here, it's something that, I don't know, I mean, actually, as she says, I mean, it's open source, so feel free to try to contribute. I mean, I'm happy to help, but yeah, I mean, we should build it, I guess.
Okay, we will contribute then.
Oh, perfect.
No. Actually, I had the same question, like, what's the requirement and process to add any news queue in your library? For example, do we have to add a driver in the library, or?
Yeah, there is a base class that you have to inherit that kind of, it defines which methods you have to support. Like just on the slides previously, you could see those methods like load, config, replace, diff, commit, discard. So you have to kind of build a class that complies to that that complies to those methods, because we want to make sure that we provide the same. I mean, that provided the same input, you are going to get the same outcome. So you have to comply with that.
Other than that, send a pull request and we'll review it. And
Thanks.
all right.
Okay.
Thank you.
Thank you.